In this video, we're going to talk about thermonuclear rocket dynamics. Well, or switching the ignition system. One of the two. All right, we'll talk about switching. The job of switching in an ignition system doesn't matter what we're using to switch, whether it's points or a transistor. The job of that is to control the negative side of the ignition coil. Remember, we always switch on the negative side. That's the switch's job. It's going to carry the current. The trigger does not carry current, the switch does. So the switch is going to carry the current and it's going to switch the negative side of the coil or ground to our coil. We've had a bunch of different switches throughout the years. We've had points, then we switched to transistors, and the first ones were pretty big. And now we have our small power handling transistors. No. Okay, that's better. We went from having these external out where they could get a lot of air to put inside a PCM, just put on a heat sink, no problem. So what we're going to do is we're going to take those and we're going to apply them to the system as I walk through some of these different systems just in kind of block diagrams so you get an idea how it was all put together. So I'm already starting out with a couple parts on the board because these parts are going to remain the same through this whole thing. And I should draw in. We'll leave the secondary out for now. In our first diagram, we have battery going to our coil, negative side of the coil goes to our points. Here, let's label this. All right, so we have our battery feeding our ignition coil, consistent voltage. All right, so we're going to have the ignition switch in here. I'm not going to draw that right now. We have our primary windings. Primary windings go over to the switch. The switch is run directly and mechanically by our cam that's inside our distributor. As that rotates, it's physically going to push the switch open and close every time it comes up on the high spots, and those points are run straight to ground. So every time that closes, we ground it, we energize the coil, current is carried across the contacts. In this case, our points. That's our switch. We went from that to So in our next iteration of this, battery to coil, that didn't change. Still switching on the ground side, but now that switch went from our points to a transistor. I'm not going to draw the transistor, you just have to imagine it. Have a transistor now acting as a switch inside the ignition control module. That's going to ground, that's going to be external to the module. Now the module is fed from our pickup, a crank position sensor, cam position sensor. Traditionally, this would have been more of a cam sensor, although we would have called it a pickup coil or something like that. That was going to feed that. That feeds the ignition control module. The module makes decisions on when to close this based on the input from this sensor, this input here. Still have a switch, still regular power. Now, the next change. In one of the next evolutions, battery feeds the coil, that didn't change. Switch inside the ignition control module, transistor, that didn't change. Our pickup, in this case our pickup coil, cam sensor, whatever you want to call it, feeds the ICM, that didn't change. What did change now is the ICM would take the information from the sensor, feed it to the ECM. The ECM would make the ultimate decision about when to actually fire this, send it back and say, okay, now it's time to do your job. In this version, a lot of times the ignition control module could actually run the car without the ECM under certain conditions, below a certain RPM. So like if we were just cranking to start up, it could start and fire the engine on its own, but then it started looking to the ECM to make decisions. Or it could run the car, but it would run it in a fixed timing. Without the ECM, it would just run it at 10 degrees before top dead center and fix it there. In this version, now our trigger simply sent a message to the ECM, then the ECM sent marching orders to the ignition control module, it ran the system. In this system, if we didn't have this line, if the ignition control module doesn't get its marching orders in this system, it doesn't do anything. This ignition control module has no ability to run this car whatsoever, because in this case, we took this pickup, or cam sensor, crank sensor, our trigger, and sent it to the ECM for it to make all the decisions based on speed and position. In the next version, battery to coil, that stayed the same. Switching on the ground side, still the same. ECM controlling it, still the same, except we moved the transistor, no more ignition control module. We took it away, we put it directly inside the engine control module. Our speed and position sensor feeds the control module handles the switching, switches the negative side of the coil. Notice this side hasn't changed yet. It's not gonna either. One last version. Now, battery, coil, speed and position sensor, trigger, ECM, doing some controlling, not switching. This version, and you're only going to typically find this in Coil Unplug, the switch has moved inside the coil itself, directly triggering the negative side of the coil. Still works on the negative. So now on this coil, we're going to have a separate ground coming in. We're going to have a wire coming from the ECM that actually just runs the transistor in here. And then we're going to have a positive that feeds the coil just like we always have. It's just going to go through the first stage to get there. So we started out fairly simple with a couple of components controlling the whole thing. And really we ended up fairly simple with a couple of components controlling the whole thing. Got a little complicated in the middle. But it's easier again. Now we just have more parts. All right, so the thing I want you to remember about all of this is the simple fact that that coil, no matter how we switch it, no matter who controls it, we always get power. That's consistent. If the key is on, that should pretty much be powered as long as relays, all that stuff are doing their job. Okay, sometimes if the key's on for a while, it won't stay powered until you crank it over, but typically, it's powered up. The ground is switched, whether we do it through a set of points, through an ignition control module, through the ECM, or through a transistor in the coil itself. That switching takes place on the ground side. Switching, ground side, constant power. Don't forget that on your ignition coils. We'll catch you in the next video.